Hey everybody, hope you're all doing moderately okay. So a customer has mailed in an iPhone 7 Plus for what looks to be repair. I'm going to say this is most likely here because they're interested in data because there's hardly anybody fixing these anymore. But let's see what we are up against. So the very first thing I notice about this phone is that we are missing the bottom screws, the pentalobe screws that hold the thing closed. And I also noticed that it has been opened before. So let's open this thing up and see what we've got going on inside, shall we? I gotta be honest, I am just a little bit terrified that this thing is gonna be completely mutilated. It has definitely been opened before. Pop it loose up top, around the edges. All right, here we go, drum roll please. Is everybody ready? Let's see what we have behind door number 1, shall we? Okie dokie, so I can see that we are missing the retaining shield that holds these connectors down. That's actually not too bad. I'm happy to say it does actually have the CPU shield on it. You wouldn't believe how many of these things show up and they're like missing, like literally missing board level components all over the place. So I'm gonna say that this thing has most likely, you know what? I'm getting just a little bit ahead of myself. I actually almost started work on this phone without doing any testing. The problem with it is most likely going to be obvious if I hook it up to a bench power supply, but before opening these things, I really like to test and see what is going on, although that's not always a really good idea because you never know what somebody has left, what terrors that somebody has left inside the phone, and you don't want to just go hook and power up to it. But here we go. I'm going to go ahead and connect a charger. Ah, yes. I was hoping that this one might be easy. We're getting a moderately steady blip, 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 blip at about a half an amp. Now that to me normally signifies we've got some sort of a main short going on. So I figured with this being an older model, it was either going to be really easy, really difficult, or completely mutilated inside. I'm going to go ahead now and disconnect the battery. Now I'm going to hook this up to a DC power supply and see what my power supply says about it. Basically just hooking that right up where the battery is supposed to go. Turning the power supply on, we are getting an immediate 3 amps of current. Now it's not that the phone is drawing 3 amps of current, it's that it's drawing as much current as it possibly can. This channel on my power supply, it's only capable of putting out 3 amps, and what this means is that we have a direct short to ground on a main power line, and this being an iPhone 7 Plus, this is almost absolutely, positively going to be a short to ground on VDD main. So I'm going to go ahead and get the board removed from this thing because that is absolutely step 1. So then I have all of the screws removed. I have everything disconnected from the board. Another thing worth mentioning is it did arrive without the SIM tray. So what do you think we're going to find here? Do you think we're going to find some nasty liquid damage, or are we going to find just an ordinary regular old round-of-the-mill VDD main short? So far, I see no liquid damage. The board looks to be pretty stinking spotless. Yeah, there really is not any visible signs of damage here on the outside. I don't see any signs of liquid damage or, otherwise any physical impacts or anything like that. So I'm just going to have a quick glance over this board with the microscope and see if there's anything that jumps out at me. I really don't think there will be. I mean, this is a very clean iPhone 7 Plus, which may also be why this customer has not requested data recovery, but repair. They know that this really should be straightforward. A lot of times on the iPhone 7 Plus, these capacitors back here wind up shorted. We do have a little flake of something there. That's surely not it. That would have just vaporized when I hooked it up to 3 amps. Another really common short, of course, is some of the caps along the Wi-Fi IC, but we really just don't have any visible symptoms here to go by. This is just a random main short, which is almost absolutely positively just going to be a capacitor somewhere. So without any visible signs to go by, we don't really want to be stuck just, guessing around on this thing. So I'm going to have a look at the board view and see what all possibilities we have for VDD main. Here we are looking at flex board view, and we can start with the battery connector, but we all know it's not going to be on the main battery line. but you can actually trace the main battery line and yada, yada, yada. And you can get down to VDD main. It's going to be on the other side of this little doohickey here. So here we are looking at VDD main. And we've got lines going to every place on the board that it could possibly be. So, you know, there's a couple of different places, not too many, but just a couple of places. So this short can be literally anywhere. And I take great pride in only taking off the stickers or the shields and only dissecting the board exactly where I need to dissect it. So what I'm going to do, I'm going to hook a ground clamp up to the bottom of the board, and I'm going to use, you know, just a multimeter probe hooked to the output on my power supply to probe around. While I'm doing that, I'm going to look at it with a thermal camera, and that's going to tell us right away exactly where the short is on this board. We'll just make it nice and easy. So for our ground, I'm just going to clamp this thing right here. That makes for a nice safe spot to hook ground. And then for our positive, I'm just going to get up here and touch these caps up here, and then I'm going to watch this with a thermal camera and see where it is that gets hot or warm or what changes. So we've hooked up our ground down here at the bottom of the board, and then for the positive lead, I'm just going to get up here and get on one side of, you know, any of these four caps. Here we are looking at the motherboard under thermal imaging, and we're just going to focus this right on in. This is the Infrared T2 or TS2 Plus or T2S Plus. The link's in the description if you're interested in what camera this is that I'm using. I really, really like this camera because of the fast frame rate, and it's practically microscopic. If you get it really close to the board and focus it, you can focus this puppy right on down to where you can see these tiny little components. I mean, this thing is brilliant for doing board repair. Okay, getting sidetracked. So I'm going to go ahead and I'm going to take, I've got my power supply set on 4 volts at, crank this up to 3 amps. There we go. And I'm just going to touch the inside. I got to try to keep my hand out of this. I'm going to go with the inside of these bottom caps. There we go. We are drawing 3 amps of current. Is it one of the caps up here that's actually Could it be one of the caps up here I'm actually touching? Okay, I'm going to move. I'm going to do the outside of these upper caps here and see if our location changes. And I'm going to watch this just a little bit closer and try to keep my hands out of it because my hands are warm. Okay, it's no. That's just my probe getting hot, and then possibly the traces inside of the board getting hot. So this short is most likely going to be somewhere else. I'm going to flip it over and see where else we can check here. Now, it's also really, really common to have shorts along the baseband IC here, this BB_RF. These caps here, this is like a whole bunch of VDD main caps. That is a really common place for this thing to be shorted. So I'm going to sort of kind of poke toward that area next. So on the top side of the board, every single one of these caps between these display chokes here, these are all VDD main, but they're all pretty well covered up by overfill, so they can be kind of tricky to get to. Do we have anything up here that's like really easy to get to? That would be nice. No, actually, all of that kind of sucks to get to. So I'm going to hook us up a wire to do this. So instead of trying to fumble around and get down in between those display chokes and do more damage to this, possibly do more damage to this board than I have to, I am just going to go ahead and solder us a probe here. This will make it easier for me to, to stay hooked onto this thing and not have to touch it with my hands. This makes it much, much easier for finding shorts. So I'm just going to take us a blob of solder here. And solder a probe on there like that. That's going to be my little test lead. Yeah, really what I'm trying to do here, I need to get a good look at the top of the board under thermal imaging. while I... Crap. Broke off. There we go, that's much better. So I'm just going to hook the power supply up now to this little jumper wire that I soldered on here. Trying to make sure I don't actually tear it off of there. And I need to get the probe, the lead out of the way. All right, so there's what we got. I've got one end hooked on ground and the other one hooked to the jumper that I just soldered on a VDD main. All right, so here we are looking at the top side of the board. And I'm going to go ahead and turn the power supply on in 1, 2, 3, on. Of course, I'm expecting my lead to get hot. Ooh, what do we have here? Okay, look at this area right here next to the CPU shield. We're going to look right, oof, man, it's all so tiny compared to my big old fat finger. Let's look right here. Okay, let this thing have a second to cool down just a smidgen. All right, I'm going to turn the power supply on. You see that spot right there? I know what you're thinking. We should give it a lot more current, right? Yeah, I agree. Let's go ahead and hit the para button. That puts this power supply in parallel mode. Now we're no longer putting out 3.2 amps, we're putting out 6.4 amps. This should be much more well-defined. I think we're dealing with one of the caps along baseband, which not the best of places, but it's also pretty easy to fix. So here we go. Turn the power supply on. Oh yeah, right there. Nice hot spot right there. And of course, look how hot my lead's getting. Let's look at that just for fun. Woo, that's nice and warm. Okay, so we can use what we learned with the thermal camera just now and have a look at the board view. So once again, switching back over to flex board view. If we look at that area of the board here, you can see we have got a row of capacitors. These are all on VDD main. So here we are looking at the side of the board. I'm going to turn the power supply on. Oh yeah, it's definitely showing up through the shield. And it's also, we can see that it's almost right at the bottom of the shield. So again, we can use that information to try to narrow this down. And for that to be almost right at the bottom of the shield, it's going to be one of these caps here, right here by baseband. So then, it's time to do some work. I think we've narrowed down, or I've narrowed down, exactly where this short is at, and I'm going to tear into this thing and fix it. So first things first, let's get rid of this big old nasty jumper wire. And while I'm at it, I'm just going to go ahead and make it look pretty. There we are. I'll come back and clean that flux up here in a little bit. All right, I've got the stickers removed and I am ready to remove this upper shield. And to remove this upper shield, we got to get rid of this little strip of glue here, which comes off, you know, it's hard as a rock, but if you get it with a little bit of heat, it'll just peel off in one strip, just like that. So there, that sticker is gone. One of the other things that we need to do, you can actually peel off, you know, the entire sticker here from one end to the other on this, you know, it's like probably like some sort of a static resistant heat transfer, you know, something to do with science sticker on top of the CPU shield. But whenever I'm just trying to remove the upper part of this shield and also put it back together, I just take my blade and I give this thing a nice little slicing right through here, like that. Once we have the strip of glue removed and we have the sticker on top here cut, we're ready to remove the shield. I'm going to switch my hot air up to, oh, let's say 450 degrees C. And I'll do an airflow of 50. All right, so we're just going to keep warming this up. Now, it is really easy to overheat this because it gets in a bind. If you just get it at one of the corners, like say if we grabbed a hold of this corner or this corner, this shield has the tendency to get into a bind and get stuck. And it can be melted, and it has a way of being melted to where you can't even really tell that it's melted. So I like to try to get it in the middle and watch very closely. There, it's starting to melt. You'll be able to see the solder. It just starts to melt. There it is, and then I roll on back. There we go. The shield has been deleted. There we are. Now, I strongly suspect that the capacitor that we have shorted is one of them in this group right here. So then, looking at this area with the microscope, it's pretty easy to see that we have one capacitor here that's got solder blobs oozing out of it. And I think there's a significant chance that that's due to me banging it with 6 amps of current. But, I mean, it could have been from solder falling off the shield, right? So I'm just going to go ahead and hook this up to the power supply once more. And I'm going to make dang sure that I don't remove the wrong capacitor. Because, again, I don't want to cause unnecessary work or make things less pretty if I don't have to. So I've hooked my power supply lead, the ground up, right where I had it before. And I'm just going to take some alcohol on a Q-tip. The power supply is still set on 6 amps of output current. I'm going to put a little drop of alcohol here, which the board's hot, so it's going to want to evaporate really fast. We're just going to see where this sizzles. So here we go. Hang on a minute, I'm having trouble getting through the coating. All right, so here we go. I'm going to touch one of these VDD main caps and see where it sizzles. Oh yeah, look at there. And there's our short right there. Nice and pretty. See it sizzling? Let's get a little bit closer for those of you sitting in the back. We're just going to get us quite a bit of alcohol on here and touch a VDD main cap. Oh, yeah. So I can say now with reasonable confidence that it's the cap on the far left. Now I'm just going to go ahead and properly remove that from the board. All right, so to remove this cap, I'm going to chunk away at the glue that's around it. Which is normally pretty hard stuff, but whenever you're heating it up to 200 degrees Celsius, it gets much softer. Now this big chip that I'm carving alongside of, for those of you who don't know, this is the baseband IC, actually the baseband CPU. This IC is responsible for all things cellular communication. So needless to say, we don't want to break it. Now if we were only after data, this phone can survive without it, but this device actually has no mention of data. It just has no power. Alright, that capacitor is already coming loose, so I'm just going to shove my blade in next to it, ka-chunk, pop it loose this way. Extra careful on the right side because that is the ceramic cap that we're up against and I don't want to crack this one, and it'll just pop right on out of there. If we leave this capacitor off of there, nobody will ever notice it. The phone will function completely fine and nothing will ever happen. But on YouTube, if you leave one of these capacitors off, you will be absolutely crucified by the audience for not putting it back on there properly. So I'm going to go ahead and warm this up and slap a brand spanking new cap on here. That way we're fixing it nice and properly. Now what I've done here, and this will also help to demonstrate how to do this without disrupting the chip next to it, I have broken this thing off here using virtually no heat at all, and I'm going to be removing this with 180 degree low melt, and I'm also going to be reinstalling it with a 180 degree low melt. So I'm going to just remove these little pads down here. I think they might have came off just now. There we are. Let's not go leaving this big old blob of garbage here on this inductor. There we go. I just want some nice bubbled up humps here that I can use to sit a brand spanking new capacitor on. Now since I have broke this off here with force and then replaced the alloy on the pads with a lower melting alloy, I can now safely float this down onto the board and not have to worry about disrupting this big old baseband CPU right here. So here we go. Let's just let this thing settle right down on here. There we go. I could have swore this was a 0402 capacitor, but well, apparently I'm installing one that's got a smaller footprint, but it's going to be just fine, right? It's going to be fine, right? And we'll clean this up with some alcohol. That way nobody can see how dirty it is after I put the shield back on it. All right, so I have installed a brand spanking new capacitor. The footprint is a little bit different, but the value is pretty much the same. And now I'm going to check to make sure our VDD main short is gone. I'm going to be putting my red probe on ground and using my black probe to do the probing. And we are now getting a 0.3 voltage drop to ground on VDD main, which that is completely acceptable. And now then, we're just going to slap the shield back on it. And I'm going to do that just by lining it up here the best that I can. So there you have it. We have the shield soldered back on, and it is slid back a little farther than it was before, but you know, that's going to be perfectly fine. I actually got down in here and I bent this little tab just a little bit so that it would still go down inside of its guide hole, and this side was really close, but I think it's in there anyways. All right, so this board is reassembled and ready to slap back in the housing, and I'm going to reassemble this and be right back in a minute. So there you have it. I have this thing reassembled into the housing, and it is just beautiful. Now, since the customers often ask if we've installed a new adhesive gasket when reassembling the phone, I have. This gasket has been really deceiving for a lot of people, thinking that it makes the phone waterproof. Aside from the perimeter around the screen, there are probably 100 different places that these phones will still leak water, so please don't get it wet. And let's peel off the protective coating here. I think everybody that does this for a living has somewhat of a love-hate relationship with this stuff, because sometimes it peels off nicely and other times it don't. This is going to peel right off nicely. Now also with this model, it's really important to give the battery connector a little bit of a touch up because they're not designed very well. They've usually been worked on several times, and I can see this one is no exception. These pins, they get recessed back up inside of here. You can see that this inside of this pin is like back inside of the plastic, and that is not good at all. We just need to push on it a little bit and bring it back out of the plastic like that. We have to make sure that that makes a connection with the battery, otherwise this phone will restart. It won't have proper battery data. Bad things will happen. So we just want to make sure and retension those battery data pins a little bit. I'm going to finish this full reassembly with the top shield, and chances are it was not the customer that left that bottom shield out. There's a very good chance that it was actually a repair shop, and the guy that sent it here has no idea that that is missing, and he is going to be expecting to get back a fully repaired phone. So with this repair, I'm going to go ahead and add that lower shield and screws and put this thing all the way back together. So then, there we go. This thing is fully reassembled, a brand spanking new adhesive gasket. I have replaced the missing bottom shield because I don't want that battery connector coming loose during shipping and then them getting the phone back and it looping and looping and looping, and then they wind up losing data because of really dumb things. And we're going to seal this thing right on up. I know I've used a black gasket on a white phone, but it's going to be... No, get my glove out of there. Yes. Now, if I'm going to go through all that trouble, and I just have these screws laying around here anyway because it's just an iPhone 7 Plus, why not go ahead and throw some brand spanking new Penelope screws in here. So there you have it, folks. I have this phone fully reassembled with a brand spanking new gasket and Penelope screws plus a retaining shield to keep the battery from coming disconnected during shipping. But does it work? I probably should have tested this. Here we go. I'm going to connect a charger. Oop, I'm on the wrong screen. No, I'm on the right screen. We got 100 milliamps, a half an amp. We have a battery charging icon, and the charging current just went from, super dead battery up to moderately dead battery up to normal charging current. I'm just going to let this charge for a little bit and see if it powers on. It will. We have Apple logo, and we're still drawing normal charging current. I'm going to let this thing boot up and make sure we have a lock screen and make sure the touch screen's working. I'm also going to check and make sure we have sound and do just a few basic checks. I don't have a passcode with this one, so I'm not going to be able to test it really thoroughly, but that's going to be just fine. Everything's going to be okay. I am just a little bit nervous that it's a white screen with a black Apple logo. We have Charge Connect. We are now up to a passcode screen. We would like to see this, switch from searching to no SIM, so now it's showing no SIM as it should. If this would have said searching at the top here instead of no SIM, that would have meant that this thing had a much, much larger problem than just no power, but this phone is going to be good to go. It is fully reassembled, and this will be a happy customer. They'll be able to use this as a cell phone, and they'll also be able to get their data off of it. So that is going to be the end of this video. I really appreciate y'all watching. I appreciate all the thumbs up and all the comments. I don't get to respond to all the comments, but I do read. I think I read every single one of them. I don't think I miss any comments. And that's it for now, everybody. Let me know what you think in the comments below. Thank you for watching, and I will see you in the next one. Have a good day.